Andy's scooter can't turn.
Hey guys, welcome to another episode of TinkMakes. This episode will be pretty exciting. It's going to be about building a scooter between the both of us.
Well, technically, 2 scooters.
Yes,
right?
2 scooters.
Yeah, so the kind of idea around this particular episode was a scooter challenge.
Yeah.
Andy's gonna build his own version of a scooter. I'm gonna build my version.
Yeah.
And we're gonna go off on a head-to-head battle to see, I guess, who makes the better scooter.
Yep. So I guess it'll be kind of like a scooter war between the 2 of us.
Yeah, a couple things before we jump into the actual video, the making video. Full disclosure, I have a lot more design and CAD experience than Andy does. One would probably classify Andy more in that kind of beginner.
Yep.
Early stage. And the software packages we're using are fundamentally different. I'm using SolidWorks, a $5,000 package.
I'm using the introductory Tinkercad, which is also free.
Yeah.
Software, and yeah, I would say it's a pretty different programs. They're both CAD programs, but what Eugene uses is more like the industry standard. Mine is more like an introductory to 3D printing, which we recommend.
It's also what we typically see in elementary schools, and what students in that kind of environment uses. It's a lot more predominant, like it's a lot more, I'm gonna call it elementary. And it's because you don't have the freedom to do a lot of stuff.
Yeah.
But and I think anyone that understands the CAD space will end up realizing that like Tinkercad is about smushing of shapes together.
While for SolidWorks you have a lot more creative freedom to actually make the shapes that you want.
Yeah.
And I mean you can also do that in Tinkercad, but it just probably takes a lot more steps than usual.
Right.
And not a lot of people would go such a roundabout way, but since our CAD experience is like
years different.
I can only use this.
Yeah. I gotta say though that design kind of experience is always going to play a big part of it.
Yeah.
Like everyone going into design is going to have a fundamentally different approach in how they're going to make something. My approach to this is going to be about reusing things I can find around every day, like pipes, boards, things like I'm going to incorporate everyday things into my build. And I think I heard that you're going to try and 3D print everything. So good luck, Andy.
I'm going to try to 3D print 90% of the things. Some things are just not doable. I mean, it doesn't make sense to print like, let's say the shaft of the scooter. Like, with the whole limitation with desktop 3D printers, it's the build space. So in order to build a shaft like this big, I'll probably have to like print like 5 parts separately.
Yeah. So the other thing that we have briefly talked about before starting this whole entire thing is cost.
Yeah.
So we wanted to make sure that this thing stayed under a specific budget. Yep. One constraint was it should be equal and or under what we can find for an equivalent scooter on Amazon.
Yeah.
That was the challenge.
Which is around $45.
Yeah. And then the second, at least my focus, is trying keeping this thing safe. Like, it shouldn't hurt anyone in the process of doing it.
I'm approaching it more as having fun and just proving that you can actually do it with 3D printing and it can still be pretty sturdy, even though there's a lot of inherent weaknesses in FDM printers.
Yeah.
I mean, yeah.
Okay, I guess without further ado, let's jump into this TinkMakes episode. It is going to flip back and forth, I think, between my view and Andy's view, and I hope you guys enjoy. So, roll the clip.
Yep.
All right.
So I'm going to be 3D printing majority of my scooter, as opposed to Eugene, where he is 3D printing some parts and then combining it with materials that he actually finds around the warehouse and then assemble into a scooter, which I actually think may be the easier route compared to mine. 3D printing majority of the scooter actually poses a lot of, I guess, issues, because If the force is applied the wrong way, the print could break because in the end, it's layer by layer built upon each other. So there is that weakness in between them, right? And also it's susceptible to heat and also limited by build space. So I actually think I am taking the harder approach to this challenge and something that I want to overcome and actually manage to produce a workable scooter in the end. So other than fun, it's also proving that I can do it. And hopefully by the end of this video, I have a workable prototype for everyone. So other than that, in the designing process, well, not process, but designing experience, as we stated earlier that Eugene and I actually have a huge gap. He's been designing for as long as I've known him for, and I actually haven't really been designing at all. I've designed here and there, but not very intricate things. More easier things like nameplates and stuff like that. And so they're pretty introductory and rudimentary. And this is actually the first challenge where I will be designing something all by myself. And I would say this is actually a pretty big project because I've never designed something so intricate. Even in the previous TinkMakes video, all those camera arms, the panning, motorized dolly, those are all designed by Eugene. I'm usually just a muscle, even though I may not look at it, but the muscle that will help him out with assembling everything. So with that in mind, my designing skills are actually very lacking and far behind Eugene. So hopefully I can actually come up with a safe prototype that Eugene can test out at the end of this video. So without further ado, let's start.
So here are the designs I drafted up in Tinkercad for my scooter. One thing I do want to stress is that knowing the tolerances of the 3D printer will help a ton. Not only do you need to model it with dimensional accuracy, you also have to take into account the tolerances or your model just won't fit together. So I designed everything to be a wedge fit and it doesn't take any screws or anything. So hopefully that works out. I want it to be simple and easy to assemble and to take apart. So as you can see here, Eugene actually graciously modeled the wheel for me so I can check if everything fits. I had some tips from Eugene and we'll probably be uploading a PDF later for any tolerances that you should watch out for before you print it and when you're modeling. Now that I have everything printed, I can start the assembly process. I made a mistake here where one side actually is slanted ever so slightly, so I didn't catch it in the program. So this is where I dip into my bag of tricks from Tinkerine experiments. I am going to use the soldering iron to soften up the top and then push the aluminum extrusion up to fix the discrepancy. Looks pretty straight to me.
Hey guys. Okay, so I think Andy's doing his video right now, and before I even get into mine, I thought I would have a conversation with you guys. This is a scooter build-off. We're both designing our own scooters, and I have a little bit more of a design CAD background than Andy does. I would say he's quite new to that. So we're gonna have different approaches to how we tackle this particular video. My concept about the whole entire scooter is we're gonna use things that we can find that are going to augment the 3D printed parts. I'm not going to fully 3D print mine, but I'm gonna focus on key components that will leverage the 3D printing technology well. That means I'm going to look for like an MDF board around shop and see if I can leverage that for my decking for the scooter board. And then I'm gonna use pipes and rods and maybe L brackets, extrusions to then support everything and bolt them all together with screws and nuts. For me, that's the right way to do it. I don't think just because you can 3D print everything that you should. And you should be strategic on where we can leverage the strength of the technology in fabrication and in making custom one-off parts if that's what you're into. So without getting too much into it, I'm going to show you kind of what I've built so far. I'm going to lay out the parts in the table in front of me, and we're going to jump right into it. So I'm going to cut to that. Yeah, the trusty Home Depot screws and bolt pegs. So most of all the 3D printed components are here. These are my hardware components. I'm still looking for a decking. Oh, you know what? Give me a second. I'm gonna use this as my deck, and it's heavy. I'm gonna part it in half, or I'll take a 6-inch block out of this. Drill some holes into it, put some bolts and screws through it, and hopefully we'll get a functioning scooter afterwards. The only thing that I have a concern over is the hub. We didn't want to, and I think Andy and I agreed on that this scooter should be as affordable as we can build it. That means that we didn't go out and buy bearings that are going to take the rotational load of when we steer it. And so I tried to design for that in here. Not 100% sure if it's going to work, though I am somewhat confident, I guess, that if we put some lubrication, silicone grease, it should be okay. Okay, so I'm going to bring this up close. So these parts have holes in them. I designed them to be a slip fit. We're probably gonna ream them out with a 8mm bit or something like that, just so that the bolts can fit right through them. I didn't aim for total dimensional accuracy, just kind of get it close enough. Finish it off with some form of machining, and then these two pieces coupled together, and well, we're gonna get a part sooner or later. So I'm gonna get assembling. I'm probably gonna do a time lapse of everything that's here, and well, we'll show you in a little bit what our end result is. So let's go. All right, so I don't know if you guys can see that. Can you guys see that? Okay, cool. So some parts I printed with supports in places that need supports. You know, for example, some parts like this one here also need supports. We have to peel them away, and for those that have never seen peelable supports, this is how they come out. Sometimes you need a pair of pliers. There you go. Fully supported parts that will fit, I hope. Let's take a look at this actually. Let me just check. All right, I'm gonna keep going. This is gonna be turned into a time lapse, and well, it's gonna just play out here. So let's go. Oh yeah, and so before the time lapse actually happens, like this is what's supposed to happen, and then this is gonna get bolted down. So all is good. let's talk a little bit about support structures. You see this? This is all waste. And where I can, I typically don't design to use supports just because of how wasteful it is. It can also add a lot of extra time just by printing all these things. There are certain components of this design that simply can't do without. So, for example, this part here, I mean, I guess I could design 2 parts, but I wanted that to be a single part. This cavity here, I had no other way of doing it. And so, this part was also printed standing up like this. And there was a ring of supports down here that supported the thing from falling over. And so, yeah, this was a pretty complex part, and well, it couldn't be printed without. So I tried to design without this wherever I can, and where I can't, well, you just have to. So make sure that you put that into consideration. It helps printing and print speeds quite a bit. Okay, back to assembly. Alright, got something to show you guys here. This part here is a hexagon. And the thing with FDM technology or filament-based technology is that things don't always end up with sharp edges. They get rounded over because the filament extrudes and expands. That means that my hexagon, which is supposed to be a perfect slit fit, doesn't fit into this. Doesn't fit into that perfectly, right? There's resistance. So I've got this file over here. I'm just gonna go in and level those corners off until they're sharp, and well, it should slide in, so let's go. Let's try this. Okay, I can't push that in. If I do, this thing is never gonna come out. I do have to put a bolt through that just to pinch everything together, and yeah, let's do that. Okay, I just assembled the, I guess this is where the wheel goes. This is the front hub, essentially. You see that hole there? There's a bolt that goes from the bottom up, and there is one of these guys. For those that don't know, this is a nylock. There's a little nylon ring in there, and once you bolt it down, it holds it in place without the need of a Loctite. Pretty nifty little nuts. Quite common, but this is a total pain. I don't have a socket deep enough that can go in, so I just spent the last like 5 minutes using this needle nose plier to twist it. And let me tell you, when it starts to engage the nylon, the resistance goes way up. But the whole idea with these nylocks is that once it goes in, you don't need to do anything else. It just holds it in place, and vibrations don't shake these loose. So safety first at the end of the day. So this is pretty assembled. The back wheel is here. If you look closely, see that? There's a little feature there. I'm gonna try and catch it in the light. That is for a V channel that will go under the decking made of aluminum. This guy. And it slots down on the bottom like so. And now when you put weight on it, the weight is transferred across the whole entire board, and this thing is wedged up against the board
it has nowhere to go, and then these little holes. Well, that's what anchors down the board to these pieces. So we're almost there. So I've just gotta go and chop that board, and like I'll be right back. Oh, one more thing. This thing. It binds a little bit. You see that like right about there. I put some oil in there. I totally forgot to put lube, silicone lube. But I've got some oil in there, some light machine oil that we use in the 3D printers for lubricating the rods. Seems to be okay. I'm hoping it'll be fine, so let's find out. Okay, I'm cutting this thing. Okay, tighten the wheel. There's a thing I would like to change with this if I could redo it again. Here, I'll turn it over to this angle so you guys can see. You see that nut head? The head of the nut, the hexagon there? I'd probably do a recess right into this part so that I don't have to have two standers when I do that. And yeah, that means it's just way easier. Only holding one wrench. Just a simplified design method. This part is effectively done. I have to make sure that the rods, these guys, tubes, have these holes in them, and I'm gonna slot them in and get this thing going. So yeah.
Okay, so after fixing my dilemma with my base, with the side, I actually have another dilemma that I guess I didn't really thought that could happen was this part where my aluminum rod is supposed to go in, and then it's supposed to be a turning agent for the front wheel. So what happened here was I did everything correctly. Well, not correctly, but the hole I measured it and made it 0.02 millimeters thicker on both sides. So 0.04 bigger than this, but then that only gives this a tight fit. So I need this to be a loose fit, and I forgot to take that into consideration. So right now, if Eugene wants to turn this, it's gonna be really, really tight. And the only thing that I think I can remedy this is sanding this rod down. So I guess that's what I'm going to be doing for the next 10 minutes.
Now that I have the deck built and all my parts printed, I can start assembling the whole scooter. Before that, I did have a small accident. I dropped this part and now it's cracked and broken. I don't want to reprint it, so I am going to have to put a ring around it to hopefully keep it intact. I modeled this part in mind where I would use a rod to hold the piece in place, but it's such a strong wedge fit that I don't think I need it anymore. That being said, I'll still include it since it was part of my initial design. Hopefully these rings will work and hold it in place. Now let's install the wheels and the handles and we can test it out.
My initial issue on this is not solved. So, if I go when I go onto this, I actually can't turn. And I just cracked it. So yeah, redo this.